In this video, we'll talk about how to evaluate the composition of trigonometric functions. So let's work through some examples. Let's say we want to find the cosine of the inverse sine of square root 3 over 2. So when we have a composition of functions like this, it helps if we just focus on the inner function first. So let's first just figure out what this value is. What is the inverse sine of square root 3 over 2? Well, when we're trying to find the inverse of a trig function, really what we're saying is what angle on the unit circle has a sine value of square root 3 over 2. So let's draw our unit circle. Now, it helps to remember that when we're talking about the inverse sine, we restrict our range of possible values to this, negative pi over 2 to pi over 2. So we're only considering the values from negative pi over 2 to pi over 2. So we're restricting our range of values that we're considering to this range right here on the unit circle. So what angle in this range has a sine value of square root 3 over 2? Well, if you think about the angle pi over 3, what are the coordinates for that angle? That would be 1/2 square root 3 over 2. And remember, the x-coordinate corresponds to cosine, while the y-coordinate corresponds to sine. So this angle has a sine value of square root 3 over 2. So the inverse sine of root 3 over 2 is just pi over 3. So this whole expression becomes the cosine of pi over 3. So now we ask ourselves, what is the cosine of pi over 3? Well, we just said over here that the pi over 3 has these xy coordinates. The cosine corresponds to the x-coordinate, so it's 1/2. So our whole answer is 1/2. So the cosine of the inverse sine of root 3 over 2 turns out to be 1/2. All right, let's try another one. Let's say we want to find the inverse cosine of sine of 4 pi over 3. So just like the last example, when we have a composition of functions like this, let's just focus on the inner one. And let's figure out what this value is. So what is the value of sine of 4 pi over 3? Well, if we draw our unit circle and we sketch 4 pi over 3, remember this is pi over 2, this is pi, this is 3 pi over 2. The angle 4 pi over 3, if we were to draw that, would land somewhere over here. So it's greater than pi, but it's not quite as big as 3 pi over 2. So here's 4 pi over 3. It helps if we can find our reference angle. So remember, that's the distance from this angle to the x-axis. So what is this distance? Well, if we imagine that pi can be rewritten as 3 pi over 3, because that's still equal to pi, what's the difference between 4 pi over 3 and 3 pi over 3? Well, that would just be pi over 3. So our reference angle is going to be pi over 3. So if we think about pi over 3, what are the xy coordinates for that? Well, that's 1/2 and square root 3 over 2. So the sine, remember, sine corresponds to the y value, root 3 over 2. But we're really working with, we want to know the sine value of 4 pi over 3. So sine in this quadrant is negative. So our sine is going to be negative square root 3 over 2. So here's what this whole thing simplifies to. This inner function we just found is negative root 3 over 2. Okay, so now we have to find what is the inverse cosine of negative root 3 over 2. Or in other words, what angle on the unit circle has a cosine value of negative root 3 over 2? Well, we know that pi over 6, if we were to draw that, pi over 6, what are the xy coordinates for that? That would be root 3 over 2 and 1/2. So I should mention the range of inverse cosine is from 0 to pi. So we're only considering angles in this range. So we found that pi over 6 has the xy coordinates root 3 over 2 and 1/2. And root 3 over 2 corresponds to cosine. So that's not our answer because we're looking for a negative root 3 over 2. But if we go over here in quadrant 2 and we think about 5 pi over 6, what are the xy coordinates on that? Well, that would be negative root 3 over 2 and 1/2. So 5 pi over 6 does have a cosine value of negative root 3 over 2. So our final answer is 5 pi over 6. All right, let's try one more example. Let's say we want to find the tangent of the inverse sine of 1/2. So once again, when we have a composition of functions like this, let's just focus on the inner function. Let's figure out what this value is. So what is the inverse sine of 1/2? Or in other words, what angle on the unit circle has a sine value of 1/2? Well, if we draw our unit circle, remember our rule of thumb up here. The inverse sine has a restricted range of negative pi over 2 to pi over 2. So when we're talking about the inverse sine, we're only allowed to consider this region. So what angle in this region has a sine value of 1/2? Well, we know that pi over 6 has the following coordinates: square root 3 over 2 and 1/2. So the root 3 over 2, this x value corresponds to cosine, and the y value corresponds to sine. So this is the angle in this restricted range that has a sine value of 1/2. So really what we get is tangent of pi over 6. What is the tangent of pi over 6? Well, if you'll recall, the tangent is calculated as sine over cosine. So we know that for pi over 6, the sine is 1/2. So we get 1/2 divided by the cosine is root 3 over 2. So remember, when we divide fractions, that's the same as multiplying by the reciprocal. So what we can write is 1/2 times the reciprocal. We switch the numerator and the denominator. So we're saying times 2 over root 3. So when we multiply these 2's will cancel out, and we'll get 1 over root 3. And usually we like to rationalize the denominator, which means we want to get rid of this radical sign. So the way that we can do that is multiply both the numerator and the denominator by root 3. So in the numerator we get 1 times root 3, that's root 3. And the denominator we get root 3 times root 3, which is just 3. So that is our final answer. The tangent of the inverse sine of 1/2 is square root of 3 over 3.